I chose my presentation on space technology, and my name is Audrey DeLong. I chose some of the newest space technology because I think that it's really interesting, and I'm hoping that you'll learn something new. And I just wanted to share some of the latest information about space and space technology that is out there today. Oh, and I'm sorry for any ads that you might see from my videos. The first one of the newest stories from November 19th is the CubeSat cannon, which there's a picture of one of them, that little tiny satellite. Right now there's 3 that just went out on November 19th. And this photo was taken by Kiyoshi Wadaka, because this deployed from the Japanese small satellite Kibo aboard the International Space Station. And these are going to help get even better images and new information out there with their size, and it's extremely low cost, and they're very lightweight. Next, we have NASA teams with asteroid mining company to crowdsource space rock hunt. Now, this is something that NASA is doing as part of their Grand Asteroid Challenge, and they just started doing it, and they're planning to team up with the Planetary Resources to find asteroid and rocks that could be a threat to Earth, or hopefully find them and it'll be for the good so we can find out about them and mine them. Let's see here. Probably just some additional information. Once again, I'm very sorry for ads that might pop up. Yes, NASA. Yep, see, there you go. NASA is partnering with the billionaire-backed company Planetary Resources, who is located right outside of Seattle in Washington, to launch asteroid hunting competitions. Now, they will be hopefully doing this early 2014 is what I read, and they're going to do competitions and offer prizes, but the government hasn't said what these prizes will be or what the competitions will exactly be on. The U.S. Space Agency and the asteroid mining firm seeking to crowdsource new ideas for software to find space rocks that could pose a threat to our planet or at least be of interest to scientists and cosmic mineral prospectors. It's the first to come out of NASA's Asteroid Grand Challenge, which launched in June. And the partnership was announced November 21st at NASA's Asteroid Initiative Ideas Synthesis Workshop in Houston. So you're there early 2014, and there are a few details about the competitions or the types of prizes that might be offered. Now, really, they're just trying to get people to get involved with finding of asteroids. And we're going to go ahead and play this video.
I'm a new mom from
And
Lakewood.
here's another ad.
Usually I shop at Giant Eagle, but today I brought my receipt.
What's going on? See here. Just want to. Well, you know what? I have a link for that. Okay. And this is an artist's illustration of asteroid Apophis near Earth. It is expected to fly really close to Earth in 2029 and again in 2036, but no threat to hitting the planet. But these are types of things that NASA and the Planetary Resource Program are trying to hopefully find so they can find out more about the asteroids and what they're going to do and what they're made of. And see, help find the asteroids. Here we go. In Seattle, NASA's planning to make asteroid mining a reality. Hopefully this video will work again. Once again, I'm very sorry for ads.
Hi everyone, this is Chris.
Yep.
Usually I shop at Giant Eagle, but today I brought my receipt to
Guess you can learn about Walmart for a quick second.
For sure.
Well, on Similac, you can save over $2 on each of these.
Awesome. If I were able to save every month, I would definitely put that in a savings account for my son.
$183.69. That's a savings of over $21 or 10%.
Really? Over a long period of time, that savings can add up.
Okay.
Chief asteroid miner here at Planetary Resources. We've been extraordinarily busy here at Planetary. It's been a while since we posted a tech update. I'm here at my desk in Bellevue, Washington, right outside Seattle, with one of the Arcid 100 mechanical prototypes that are under production here in the shop. The Arcid 100 is our space telescope and technology demonstrator for our prospecting missions. Now, one of the earliest decisions we made was to design and build as much as possible in-house, right here at Planetary. This is much the same way that Elon Musk and SpaceX have vertically integrated to drive innovation, control reliability, and to keep costs down. And this is going to allow us to mass produce our spacecraft at extremely low cost. The first thing I'd like you to notice about the Arcid 100 is that it's daringly small. This cuts the cost of deep space missions below anything we've become accustomed to. Our engineering team is packing tremendous capability into this small package, and this will give us more launch opportunities to get our spacecraft where they need to go in the solar system. So as I lift the prototype, you can see the density of everything that we've packed into these 11 kilograms. From our deployable solar arrays, to the integrated avionics bay on the bottom, and our instrument and sensor package at the back of the comparatively large optical assembly that really dominates the volume of the spacecraft. Of course, what you can't see is the innovations that we're developing in the flight software, but our software team will assure you that they exist. Without divulging our intellectual property, I can tell you that we're working to make this the most advanced spacecraft per kilogram that exists today. We're drawing on our experience from traditional and private space exploration and combining it with exponential technology developments of the past few years and those to come in the next few years. With all of this, we're raising the bar on spacecraft design above anything that's been done before.
Okay. I was explaining it and how small they are. Let's go back. Okay, now this little gadget is also a brand new story. It's a European space ball that could bring samples of Mars to Earth. And so a picture of Mars, and that's what it looks like. All those little capsules would be full of samples they could bring back from Mars. And this should be a quick video. Probably another ad. Yeah, there's Walmart.
I'm your mom from Lakewood. My name is Betty Jean. Usually I shop at Giant Eagle, but today I brought my receipt to Walmart.
But basically this is a mini ball that the ESA, the European Space Association, the ESA has built to collect samples from Mars and keep them in pristine condition as they journey back. And it incorporates mechanical systems covering structural, thermal, and mechanism engineering, but also communications, antennas, and power. There's 11 receptacles stored under 14 degrees Fahrenheit, and they weigh less than 11 pounds. And that's all it is. Thought that was pretty interesting. Now, this is probably my favorite thing. 3D printers that are coming into space. This is a program made in space. These guys are on a 3D printer and they're holding on to it while performing a zero gravity test. That's what they're doing. That's the printer. Now, the 3D printer is going to be small enough to fit inside the MSG. Crew members will put their hands inside a glove box to operate it. Let's see, there's a short video for it. Yeah, so we'll hopefully show that 3D printing is just as successful as it is on Earth. So for those on the space station, they don't have to wait for parts to be sent or bring a bunch of spare extra parts, because they could just make the parts they need right there, which is pretty cool. Alright.
And she is the 3D print project manager here at Marshall. Nikki, first of all, tell us what 3D printing is all about.
Hi, Lori. Happy to. Thank you for having me. 3D printing. A 3D printer will extrude plastic, metals, or other materials to build layer on top of layer to create a three-dimensional object. So you might be able to print all sorts of tools, spare parts, things like that.
So it kind of sounds like the Star Trek replicator, right?
Absolutely. We get that a lot, and it is the first step toward that.
Tell us how it all works.
Okay, the 3D printer that we're going to fly on Space Station will actually be the first ever 3D printer in space. There are tons of printers many people have heard about on the ground. As a matter of fact, my 9 and 11-year-old daughters are asking for one for Christmas. They have them at Staples and places like that, and you can create all kinds of things with them. But the one that we're looking at for microgravity, of course, we want to build space parts. So the design optimization is very important. As we all know in space, you have to wait for, as you mentioned, the resupply ships if you need a spare part, or you have to fly a lot of spares up, which take considerable mass and which cost money. Also, things break, and things do actually get lost. We've been on Space Station for quite a while, and things get sucked into corners and crevices.
No.
Yes, it happens. On top of that, there are unique type of things that we could do if we had a capability to build in space. For example, CubeSats. Many people have heard about these small CubeSats, and with the onset of nanosat technologies that we have, these are used for all sorts of things in academia, commercial, and you actually can deploy them from the space station. If we were able to print these on orbit, the crew could assemble them and deploy them from station. You can do all sorts of unique structures and just an abundance of different types of experiments.
So this one was built here at Marshall?
Yeah, this one was printed here, and this is just kind of the case of one. It's got some electronics that go inside, and you deploy from station.
So how long does it take to build something like that?
Something like this would actually only probably take an hour, hour and a half. And then you also have things like this. It looks pretty non-assuming. It looks pretty simple. You could print this probably in 15 to 20 minutes. We would just upload a CAD drawing to the printer on station. But what this is actually is MSG, an extraction tool that they did not have on orbit. And actually MSG was down for around 6 months waiting on a resupply ship to bring this up. This is something with the 3D printer capability that we could have actually printed out on orbit within 30, 45 minutes, able to go.
Wow, what else do we see here?
We've got some other just fun things. Of course, people think of crew tools and wrenches. We've got a metal one here, too, and we're starting with plastics for this first printer, but we will be moving to metals and other types of materials. We've got things like, you can imagine, different size sample containers. You can also do interactive... That wouldn't happen in space. So you have interactive parts like this that can move. You can do complex parts as well with unique structures.
So tell us about the unit that is actually going to station.
So we're working with the company Made in Space. They're actually located at Ames Research Center, and the project is led here out of Marshall Space Flight Center. It's a really good interaction between this commercial company, whose business model is to create a commercial additive manufacturing 3D printing facility on Space Station. This is the first step. It is a technology demonstration. We'll operate inside the microgravity science glove box. And NASA has been providing the discipline expertise and the expertise in terms of taking a printer that you would use on the ground, which Made in Space are absolute experts on that, as well as designing for space, and making sure that we can verify that for microgravity, the physics of microgravity, as well as the safety and operational constraints in the controlled environment of Space Station.
And this is all.
So that's probably my favorite one. That the fact that they don't need to bring as much into space and no extra tools. They can make any tools they may need right there instead of waiting months and months to get them. And last, we have a man who I found him on TED Talks. So, I love that show. So, his name is Carter Emmert. Carter Emmert is one of the main authors to help develop the Digital Universe Atlas. It is a standalone four-dimensional space visualization application. Digital Universe shares the capacity to visualize space from points outside of Earth. He and other authors helped develop a very cool way to see the Earth and see the Earth in a 4D way.
It's a great honor today to share with you the digital universe, which was created for humanity to really see where we are in the universe. And
I'm going to see if I can restart that. His lips weren't really matching up with his voice.
it's a great honor today to share with you the digital universe, which was created for humanity to really see.
His lips aren't really matching up with his voice, but I'm just gonna play it anyways, and you'll get the picture.
Where we are in the universe, and so I think we can roll the video that we have. The flat horizon that we've evolved with has been a metaphor for the infinite, unbounded resources, and unlimited capacity for disposal of waste. It wasn't until we really left Earth, got above the atmosphere, and seen the horizon bend back on itself, that we could understand our planet as a limited condition. The digital universe, Atlas, has been built at the American Museum of Natural History over the past 12 years. We maintain that, put that together as a project to really chart the universe across all scales. What we see here are satellites around the Earth, and the Earth in proper registration against the universe as we see. NASA supported this work 12 years ago as part of the rebuilding of the Hayden Planetarium so that we would share this with the world. The digital universe is the basis of our space show productions that we do, our main space shows in the Dome. But what you see here is a result of actually internships that we hosted with Linköping University in Sweden. And I've had 12 students work on this for their graduate work, and the result has been this software called UniView and a company called Skis in Sweden. This software allows interactive use, and so this actual flight path and movie that we see here was actually flown live. I captured this live from my laptop in a cafe called Earth Matters on the Lower East Side of Manhattan, where I live. And it was done as a collaborative project with the Rubin Museum of Himalayan Art for an exhibit on comparative cosmology. And so as we move out, we see continuously from our planet all the way out into the realm of galaxies, as we see here, light travel time, giving you a sense of how far away we are. As we move out, the light from these distant galaxies have taken so long, we're essentially backing up into the past. We back so far up, we're finally seeing a containment around us, the afterglow of the Big Bang. This is the WMAP microwave background that we see. We'll fly outside it here just to see this sort of containment. If we were outside this, it would almost be meaningless in the sense it's before time. But this is our containment of the visible universe. We know the universe is bigger than that which we can see. Coming back quickly, we see here the radiosphere that we jumped out of in the beginning, but these are positions, latest positions of exoplanets that we've mapped. And our sun here, obviously with our own solar system,
But you're going to see we're going to have to jump in here pretty quickly between several orders of magnitude to get down to where we see the solar system. These are the paths of Voyager 1, Voyager 2, Pioneer 11, and Pioneer 10, the first 4 spacecraft to have left the solar system. Coming in closer, picking up Earth. Orbit of the moon, and we see the Earth. This map can be updated, and we can add in new data. I know Dr. Carolyn Porco is the camera PI for the Cassini mission, but here we see the complex trajectory of the Cassini mission, color-coded for different mission phases, ingeniously developed so that 45 encounters with the largest moon, Titan, which is larger than the planet Mercury, diverts the orbit into different parts of mission phase. This software allows us to come close and look at parts of this. This software can also be networked between domes. We have a growing user base of this, and we network domes, and we can network between domes and classrooms. We're actually sharing tours of the...
So that was a really awesome model of what he was doing and what researchers have done. And so he created that, and it was a very cool aspect to see the Earth and then everything outside of the Earth, from the solar system to the Milky Way and even beyond that, which he said was even pretty much before time. So, well, that's a little bit hard to read, but I hope you all have enjoyed the video, and I hope you learned something new and have a new interest in finding more things out about astronomy and space. Thank you.